Yo, what's up everyone? Patrick here, welcome back. Moving on to the next video. We got to simplify each of these four expressions over here. So the first one, we got x to the 6 over 16, y to the negative 8, all to the power of negative 3 over 4. Now, for all of these expressions, there's actually different steps that you can take to simplify these. You don't have to follow the exact same steps that I'm taking. In fact, what I recommend is you pausing the video here and actually trying these on your own. Try to simplify, test yourself, and then you could compare the answers at the end. And then you could see the difference in the steps that you took and I took to potentially come up with the same answer. It's going to increase your understanding more of how all of these rules work. So over here, the way that I'm going to do this one personally is I'm first going to work with simplifying this bracket here. Now, there's nothing that's going to cancel out. But what I like to work with is positive exponents if possible. So this y to the negative 8 I'm actually going to bring up. So I'm going to rewrite this as x to the 6, y to the positive 8 all over 16, like that. And then the exponent's going to stay the same, negative 3 over 4. And then what I'm going to do is I'm actually going to change this exponent now to a positive. So I'm going to flip this. I'm going to flip the whole fraction. And now this is going to become positive 3 over 4. Now you didn't have to do that. You could take this exponent, distribute it to all of these, but then you're going to have a bunch of negative exponents. You're going to have to flip those eventually. So I'd rather just flip everything here and then change this to a positive and then distribute it in the bracket. So we would have 16 to the power of 3 over 4. So we're going to distribute this to the numerator. And then that whole denominator is going to go to the power of 3 over 4. Then over here, we're multiplying terms. So what we can do is we can take that x to the 6 to the power of 3 over 4, and then we could take that y to the 8 to the power of 3 over 4 as well. And then over here, 16 to the power of 3 over 4 is like 16 to the power of 1 over 4 to the power of 3, which is 2 to the power of 3, which is 8. So this here is going to be 8. Over here, we would end up with 18 over 4, which would be 9 over 2. Right, so this would be x to the power of 9 over 2. And then over here, this would end up being 6, right? 8 times 3 over 4 gives us 6. So this would be y to the 6. So this here is the final answer. So again, different steps that you could take. Even at this point, you may have just distributed, right, the negative 3 over 4 to this, this, and this. But after you simplify, after you have pure positive exponents, you should end up getting 8 over x to the 9 over 2 times y to the 6. So that's the answer for number 1. Now, number 2, what do we got here? We have x to the negative 5 over y to the negative 3 to the power of negative 3, and then x to the 2 over y, all to the power of 2. So first thing I'm going to do with this one is I'm going to switch these up in the bracket over here. So y to the negative 3 I'm going to bring up, and then x to the negative 5 I'm going to bring down. So this would end up being y to the 3 over x to the 5, and then this exponent is staying the same. Over here, I'm going to distribute that exponent. So I'll have x squared to the power of 2, and then I'll have y just to the power of 2. There's like a y to the 1 there, like that. There was no negative exponents. This wasn't negative, so I might as well just distribute at this point. And nothing cancels out here either. And then over here, because this is a negative, I'm going to flip this, change that to a positive. This would end up being x to the 4 over y to the 2. We're multiplying here. And then we would end up with x to the 5 to the power of 3, which would be x to the 15. And then y to the power of 3 to the power of 3 would be y to the 9. And then we got x to the 4 over y to the 2. These two are multiplying, so we'd end up with x to the 19 over y to the 11. So that there ends up being the final answer. And then we got number 3 here. We got the 4th root of x to the negative 1 times the 3rd root of 8x to the negative 6. So first thing I'm going to do is I'm actually going to change these square roots to rational exponents. So this fourth root of x to the negative 1, I could actually rewrite that as x to the negative 1 to the power of 1 over 4, like that. And then this over here, I could change to be 8x to the negative 6 to the power of 1 over 3, like that. And then from here, I'm going to change x to the negative 1 as 1 over x. It's like 1 over x to the positive 1, and then you don't have to write the exponent. Then I got 1 over 4 here. And then this I'm going to change to 8 over x to the 6 to the power of 1 over 3. So then 1 to the power 1 over 4, that's just 1. X to the power 1 over 4, we would just write like that. 8 to the power 1 over 3 gives us 2. And then x to the 6 to the power of 1 over 3, that would just be x squared, like that. And then notice 1 times 2 is 2, and then these two, we can multiply these, and then since they have the same base, we could add the exponents. So 2 plus 1 over 4 would be like 8 over 4 plus 1 over 4, which would give us 9 over 4. So this would be x to the 9 over 4, like that. And if you want to make this in radical terms, you could change this to x to the 9 and the fourth root of that. This and that are the exact same thing. I feel like it's, yeah, both are pretty nice. I usually just leave it like that. But depending on your teacher, they may want it in that format. So either of these is the final answer to number 3. And then number 4 is actually not too bad at all. It's pretty simple. Again, I'm going to follow that same process where I'm going to take that fifth root and I'm going to change that to a rational exponent. So change it to the power 1 over 5. So this would be 32 x to the negative 5, y to the 10 to the power of 1 over 5. And then over here, what I'm going to do first is take that x to the negative 5, bring it down like that. And then everything has to go to the power of 1 over 5. So this would go to the power of 1 over 5, this y to the 10 would go to the power of 1 over 5, and then x to the 5 would go to the power of 1 over 5, like that. Right? Because all of these terms are either multiplying or dividing, we can take that exponent and distribute it to all of the terms. So because we have something like this multiplying, or there was even something in the denominator there, basically we can do that. We just took all the terms and put them to the power of that exponent. But if this was like multiplying, or adding, let's say, then we can't just do a to the x plus b to the x. This here would basically be a plus b to the x over c to the x, like that. And then this here, you can't simplify any further. You can't do a to the x plus b to the x. This would be the simplified version. We're not dealing with that case, but thought I would mention it. So over here, 32 to the power 1 over 5 is just 2, right? The fifth root of 32 is 2. 10 times 1 over 5 is 2. And then 5 times 1 over 5 is just 1. So there would be just an x left there. So 2y squared over x is the final answer for number